So here we're going to do problem 3. It extends across 2 pages, and the printout sucks. So this little part over here is supposed to be part of this matrix here. So now the question is, match each of these matrices to their corresponding transformations. Now these matrices are 2 by 2 matrices, so we know they're going to be for 2D points. So we're going to have an xy point that's going to be multiplied times this matrix here. And so the question is, what do they do? So this matrix, because it has components in the diagonal here, this is going to be a scaling matrix. And we can see that if we multiply it out. So our ending point, this is going to be equal after we do this multiplication. We're going to have some x prime, y prime. Okay, this is going to be equal to x and negative y. So what we can see is that we're going to flip over the y-axis. So if we go look for something where our robot flips over the y-axis, then we should be in the right place. Now, we weren't given the starting location in this case, which is kind of annoying. We would like it if we had a picture of what we started from, but we're just going to assume that we started with a robot near the origin in the upright position. So here's something where we've flipped over the axis. So this is going to be A, because we've flipped over the axis. Now this next one is also a scale. It's a scale by 2.5. So we're going to have 2.5x, 2.5y. So here is a big robot that looks like it's going out to sort of 2.5 by 2.5. So this is going to be B. Let's skip over this for a minute. It's probably a rotation. We're not sure. So this, we have a scaling by 1.5 and 2. So here we've got x goes by 1.5, y goes by 2. So this is going to be D, because this was a scaling matrix. Now, this remaining thing, to really be sure what's in here, we would have to check it. So a rotation matrix is going to be equal to cos alpha, sine alpha, negative sine alpha, cos alpha. I invite you to forget this by the time you end this class, but don't forget it before the end of this class. You need it in order to do your homeworks and tests and things. So this matrix right here does not look like this form here. So now the question is, what's going on? Well, this might really be stacked up with multiple different things, right? So the reason I'm saying that this doesn't look like the same is I have a cos alpha, and here I've got a negative, and here I've got a positive, right? So something is not matching. What am I expecting it to match? So this is not just a pure rotation matrix. It's going to have to be a rotation with some other kind of thing mixed in it. So let's look at another way we can try to get at what's going on. Of course, we can just do process of elimination. So by process of elimination, this thing is definitely C, right? But we'd like to have a better answer than that. So if we imagine multiplying our points, I have my xy here. This is going to be equal to negative radical 2 over 2x plus negative radical 2 over 2y, and then negative radical 2 over 2x plus, and this is a sign change now, radical 2 over 2y. So we just have to take some points. So let's consider the point at 1, 1. Well, let's consider the point at 1, 0. It'll be easier, right? So if we have a point at 1, 0 here, we stick it into here, we're going to have x, this 1, 1 point. So approximately the bottom foot of this thing, is going to go to where? It's going to go to negative 2, negative radical 2, negative radical 2, right? So it's going to go to some place down over here. And let's consider the point near 0, 0. So what's this going to be when it multiplies in? These are going to be zeros, everything's going to be 0.